experiment is to study the dependence of current I on the potential difference V across a resistor and determine its resistance, and also plot a graph of V versus I. The apparatus required to perform this experiment are a nichrome resistor, a rheostat, dry cells, a battery eliminator, a plug key, a voltmeter, an ammeter, connecting wires, and a sandpaper. Let us now begin with the experiment. First, take the voltmeter with a range of 0 to 5 volts and the ammeter with a range of 0 to 1 ampere. Note the zero error and least count of the voltmeter and the ammeter. In order to find zero error of the voltmeter or the ammeter, look for the position of the pointer in both the instruments before connecting it in the circuit. If the pointer exactly coincides with the zero mark, then the instrument does not have a zero error. Here, we can see that the pointer exactly coincides with zero mark in the voltmeter as well as in the ammeter. This means that both the instruments do not have a zero error. Hence, the observed readings do not need correction. But if the pointer coincides with another division instead of zero mark, then that division should be subtracted from the observed reading to get the corrected reading. For example, when the voltmeter is not connected in the circuit, the pointer of voltmeter coincides with the first division. That is, voltmeter shows reading as 0.1 volt. When the current is allowed to pass through the circuit, voltmeter shows reading as 0.9 volt. Then the corrected reading is equal to 0.9 volt minus 0.1 volt, which is equal to 0.8 volt. Let us now note the least count of the voltmeter and the ammeter. The least count of the voltmeter is 0.1 volt and the least count of the ammeter is 0.05 ampere. Let us now proceed further. Scrub the ends of the connecting wires with the sandpaper to make better electrical contact. Now, connect the components of the circuit as shown in the circuit diagram with the help of the connecting wires. Keep the plug key open. This experiment can also be performed by increasing number of cells in the circuit. Note that, in this case, rheostat is not to be used. Here, we have used a battery eliminator, so we can adjust the current flowing through the circuit by sliding the variable terminal of the rheostat. Now, let us start taking readings. Switch on the battery eliminator and keep the knob on 5 volt. Close the circuit by inserting the plug in the key. Now, slide the variable terminal of the rheostat to obtain the reading of 0.1 ampere in the ammeter. Once the rheostat is adjusted for the desired reading, note down the voltmeter reading. Let us record these readings in the observation table. For current of 0.1 ampere, the voltmeter reading is 1.5 volt. As the ammeter as well as the voltmeter does not have a zero error, the corrected reading will be the same as the observed reading in each case. Let us now increase the current in the circuit by sliding the variable terminal of the rheostat till the ammeter reads 0.15 ampere. Note the reading shown by the voltmeter. The voltmeter shows 2.3 volt. Enter the values in the observation table. Repeat the same procedure for another 3 values of the current. For current of 0.2 ampere, the reading of voltmeter is 3.0 volt. For current of 0.25 ampere, the reading of voltmeter is 3.7 volt. For current of 0.3 ampere, the reading of voltmeter is 4.5 volt. Remove the plug key after taking all the readings and disconnect the circuit. Let us now calculate the resistance of the given resistor, that is, the ratio of the potential difference V across the resistor to the current I through the resistor using the formula R is equal to V upon I. Enter the calculated values of the resistance in the observation table. Let us now plot a graph of potential difference V versus current I. Mean value of the resistance is equal to 15.02 ohm. Inference 1. As the current I in the circuit increases with the increase in voltage V as well as decreases with the decrease in voltage V, it means the ratio of voltage to current is constant. This verifies the Ohm's law. 2. The value of the unknown resistance is 15.02 ohm. 3. The graph of V versus I is a straight line passing through the origin O, 0, 0.